Alrighty. Let's learn about the election process. And let's do certain comparisons. Because there's a little bit of confusion out there. Not confusion. Just people like to learn the hard way. For whatever reason. Alright. This is the same example as before. Same switches. I didn't move it around. Alright. And we said that this was the root bridge. Now, span tree has its criterias. To elect the root bridge. And let's bring out Notepad. There it is right there. I'll bring it down here. Perfecto. Okay. So STP, put all in caps, STP, election of root bridge criteria. First thing that it looks for, it is the bridge ID. Let me change that. Got ahead of myself. Priority number. What is the priority number of every switch by default? 32769. Every switch, every Cisco switch, I'll say it that way, has a bridge priority number of 32769. So span tree takes a look at that. Says, well, wait a minute, if everybody's 32769, then I cannot use that because we all have the same number. It's looking for the lowest bridge priority number. Okay? So if it can't use that, what does it default to next? MAC address of switch. Again, lowest. So obviously, this must be the lowest MAC address, or this switch here has a lower MAC address than this one. So it chose that one based on the MAC address of the switch. Now, the combination of these two, the priority number and the MAC address, is called the combo of MAC, or I should say priority and MAC, is called bridge ID. Okay? So that's for the election on the root bridge, and let's prove that. Let's open up this one right here. Let's maximize the screen. Okay? Enable, and we know the command now. Show spanning tree, correct? Show spanning tree. I tab. All right. Now, one thing that we didn't talk about in the previous lesson. All right, I didn't want to get too much into detail. This portion of it right here. Doesn't matter what switch you're in. Does not matter what switch you're in. This portion of that you're looking at right here that's highlighted, that has to deal with the root bridge. And this portion down here has to deal with the switch itself. All right. So in this case, the information is going to be the same because this is the root bridge. So the MAC address obviously is going to be the same. And you can see that we're using a default priority number. All right. And we have seen this before in the previous lesson. But again, it chose it because it has a lower MAC address. That was my statement. All right, so let's see. 00, well, you'll see this MAC address on the other switch. Because remember, this information will go across all switches. So let's go to the other switch. Let's maximize it. Enable. Show spanning tree. So here's the MAC address of the root bridge. And here's the MAC address of this switch that we're in. Well, now you see that E is greater than D. So this is a higher MAC address. So indeed, since it could not use the criteria of the priority number because they're all the same, it chose to go to the second option and say, hey, I'm going to go ahead and choose the one with the lowest MAC address, and that one's going to become the root bridge. Now, they'll mention it. I'm pretty sure they'll try and say, who's the one with the lowest bridge ID? All right, so again, they'll give you, remember, the combination of the priority number and the MAC address creates that bridge ID. So just pick the lowest one. Okay, pick the lowest one. And that will be your lowest bridge ID. But you can see that the MAC address is bigger than the other one. But what ports? Okay, so now, so we have other criterias that we need to think of. So let's draw a line here. STP, let's put it in caps, STP, election to block a port. How does it decide? Well, first it picks the switch, TCH, with the highest, can't spell, highest MAC address, right? And we just saw that. The second criteria, it says, okay, which port do I block? First thing it looks for is, okay, let's look at bandwidth. They're all at the same bandwidth. These are fast Ethernet ports. So it's going to be, can't use it. There's no tiebreaker there. Same bandwidth. So it would choose the slowest bandwidth to block. So since it couldn't use bandwidth, it will choose the highest port number to block. Why the highest port number? Higher MAC address. Because that port number has a higher MAC address than the lower port number. Let's prove that. So let's come back here. This is a switch with a higher MAC address, so it chose to block a port. As you can see, it blocked the highest port number. But let's take a look, and let's maximize it. Let's take a look at the ports. Show, okay, come on now. Show interface F0/1, right? Here's the MAC address of port 1, okay? So let's look at the MAC address of port 2. Port 2, okay, it looks similar, except the last portion of the MAC address is 7202, where the other one is 7201. So this one is 7201, and the one for the other port 2 is 7202. So it has a higher MAC address, and that's why it chose to block that port. So let's talk about this again. We have two switches that are connected to each other. Since we want STP is on by default. The job of STP, as we said earlier, and in the previous lesson, that its purpose is to prevent switching loops, and the way that it does that is by blocking a port. Now, how does this election take place? First, it must elect a root bridge, and it elects the root bridge by choosing the switch with the lowest bridge priority number. But since they're all the same, the 32769, it has to go to the second criteria, which is the lowest MAC address. So this switch over here, since it had the lowest MAC address, this became the root bridge. Therefore, these ports became designated forwarding ports. Okay? So the only other switch here, this must have had a higher MAC address, and we verified that this had a higher MAC address, so it chose that to block a port on. So which port will it block? Well, it needs to choose between one or the other. The bandwidth is the same. The cost, 19. Fast Ethernet. so it can't use that. But this F02 is a higher port number that has a higher MAC address, therefore it will block that particular port right there. All right, so that's how it works. And in your certification, when you're asked questions on to pick, you know, types of ports or who's a root bridge and what have you, the first thing you need to identify is who is the root bridge and work your way from there. Work your way from there. Now, I did say this, then I don't want to cause any confusion. I said every port that faces the root bridge must be a root port. So you must be thinking, well, Laz, this is not a root port, it's a block port. Well, it has no choice. It's got to block it somewhere, right? So it had to block this one. If not, you will have a continuous loop and your network will go down. If not, you can do a test in your test lab, not in your real life lab, in your test lab. You take a straight through cable, you plug it into port 1 and port 2, whatever ports, in the same switch, and you're going to create that loop. And you're going to see how you're going to bring, boom, that's going to go down ASAP. All right? Trust me on that one. Okay? All right, so now let's change the bandwidth. Let's take out that port right there, that F02 port, that link. Let's take that link out. And let's put a gigabit link and see what happens. All right, and remember, span tree only really comes alive. It only really comes alive and does what it has to do when it finds redundant links. So here, there is no redundant link, so really it doesn't matter. What did I say? Oh yeah, gigabit port. All right, so I'm actually choosing a port. I choose gigabit. I'll use the last port. Gigabit is 1.2 to gigabit 1.2. Okay. And let's see which port it blocks now. Span tree is doing its magic. It's working. It's thinking, oh my God, what's going on now? Something changed. I need to recalculate. The costs have become different. Now gigabit is 4, where Ethernet is 19. All right, so let's see what's going to happen. It should happen any day now. Really it will. That's why we have rapid spanning tree, so it can go faster. Here we go. As you can see now that the higher port is not blocked. The higher port is going to be designated forwarding, but the lower port is the ones that blocked. It makes sense. It makes sense. Let's take a look at it. Why in the world would you want to block a gigabit port? Show spanning tree. There it is. Right? Your F01 alternating block, right? 19 cost. Gigabit port, root, forwarding, cost 4. So that's why. That's how that works. It's based on bandwidth. It's based on bandwidth when looking to see what port is going to block. So it will use bandwidth. It looks at the bandwidth. All right? Someone say, no, it doesn't. Yes, it does. All right? Cisco has its calculation that you guys can go ahead and calculate across 19 plus 4 plus 28 and all this. So you don't need to do all that. All right? And those of you that say, well, how about 3 switches? How about 4 switches? How about 10 switches? Well, if you want to calculate that, you go right ahead. Normally, you don't even mess around with that. All right? Your switches are in place. Heck, people have a hard time creating VLANs, much less tweaking spanning tree. Okay? But you really don't tweak the spanning tree. You let it decide who's going to be the root bridge unless you have a specific beefy switch that you want that one to be the main switch, and then things will propagate from there. All right? But so you can see the election process. Again, you're taking a certification exam. Keep that in mind. All right? So again, the election process, this is what happens. But you see that now the higher port number actually didn't get blocked because it had a faster bandwidth. So it used that particular criteria that we have written down here. All right. The second one, that is going to block the slowest bandwidth to block. And it did. It blocked the fast Ethernet, not the gigabit. So that is the election process of of span tree. But let's take it a step further, all right, because you're going to be working, when we do our labs, we're going to be using 3 switches. So I'm going to get a switch out here. I'm going to put a switch out here. And I'm going to put a switch out here. And again, I'm going to cheat. I'm just going to let it plug in whatever port it wants. Doesn't really matter to me at this point. I'm just trying to show you how this selection process takes place here with 3 switches. Okay? So you can say, oh, we only did 2 switches. Here's 3 switches. All right, let's put it over here. So span tree, again, takes anywhere up to 90 seconds for it to do what it's got to do. Like I said, there's different versions of spanning tree, right? This is the original version of 8021D. You do have your rapid spanning tree, all right? And there's also rapid spanning tree with PVST, and there's like 4 different types of spanning tree. Basically, all that does is how many spanning tree per VLANs you can have, or how quickly it can converge, okay? So here, looking at this, we know right off the bat that that's blocked, all right? Just like we know that that's blocked. So obviously, this is the one with the highest MAC address. I didn't change priority numbers. I didn't do anything. So this is the one with the highest MAC address. So this is blocked. So this is definitely not the root bridge. Okay. And I said, excuse me, I said that every port that faces the root bridge must be a root port. Well, there's a block port. So if it's facing that switch, this is not the root bridge. So this guy over here is the root bridge. Let's see if that's true. Let's open this guy up right here, switch number 3. Let's maximize it. And the command is, very good, show span tree. And lo and behold, this is the root bridge, right? So there's the MAC address, 0001, okay. And all those ports are designated forwarding. We got the same bandwidth as 19. This is something you really need, a screen you need to pay attention to. You need to know that this portion is for the root bridge, this portion is for the switch. All right, take a look at the ports if they're designated or root ports or block ports. You need to take a look at that. It's going to be very important for your switching simulation. All right, show span tree. All right, so we see that the MAC address there, perfect. We know that this is the root bridge. We verified that because it says it. This is a root bridge. Or just take a look at all the ports. They're designated forwarding ports. Designated forwarding ports. So that is a root bridge. All right, well, let's take a look at this switch over here. All right. Show spanning tree. Okay. Now this is, whew, I'm growing up. I'm changing my voice. All right. This is the MAC address of the root bridge. Okay, this is a higher MAC address than this one. Okay, 0006 versus 0001. So, okay, that's why he did not become the root bridge. You can see that they're using the same priority numbers. So it didn't choose that as a criteria. And look at his ports. One's designated forwarding, one is root. Root, important. Root, this is the one facing the root bridge. What port is facing the root bridge? Port F02. Sounds like a test question to me. All right, so show spanning tree. You see that this port is a root port and that root port is facing F02. Hey, I may want to do show CDP neighbor. Show CDP neighbor detail. Take a look at that name. Switching simulation. Okay. Anyway, all right, so this has a high MAC address, 0006. So keep this in mind right here. Keep this in mind. Let's take a look at the switch that actually got blocked. Enable, show spanning tree. And there's your root bridge. Oh, okay, look at that, 005. The other one was at least 0006. This is 005. Definitely this has the highest MAC address. Port 1 is the root port, which is facing the root bridge. The other one is just the one that they decided highest port to pick to block. So information will not be forwarded out that port. So there you go. Span tree does it all on its own. But in other lessons to come, I will show you how to manipulate that. But so you can get an understanding of how spanning tree works and what command and what is it that you're looking at. All right? Because we will learn to manipulate spanning tree. We will even learn how to turn off spanning tree. Okay? But that's in lessons to come. So understand the election process. Because I know that sometimes it becomes difficult because a lot of people like to use, and Cisco does do this, they use the lowest cost path. Write that down. Lowest cost path. If you ever run into a question in an examination at your school, lowest cost path to the root bridge. Okay? But again, we see now the trick, right? I find the root bridge. These are my designated forwarding. These are my root ports, my block port, and another designated forwarding port. Okay? That's all there's to it. All right, but you got to practice that. You got to practice. You got to look at this video over and over and over and over again so you can get that spanning tree and do the practice. Don't go crazy hooking up 10 switches and try and figure out what's it doing. The maximum you should go is 4 switches. Max, okay, is 4 switches. Other than that, get the idea of the criterias that spanning tree is using to block ports. And the whole purpose of it is just to avoid switching loops. And in a real world scenario, doubtful that you'll be tweaking spanning tree. All right, but for the test, you need to know these ports and how they become these ports. Okay? All right. I'll see you guys in the next session or lesson.